So let us see what is meant by J operator. Let us see what is meant by J operator now. Connectivity issue. So J operator is a mathematical operator, okay, so which is when multiplied with any vector, that vector will shift its angle by an angular displacement of 90 degree. So if you see, there is a voltage vector here E. So this voltage vector will be shifted by an angle of 90 degree in anti-clockwise direction because of multiplication with J vector. So when you multiply E with J, what will happen is there will be an angular displacement of by a 90 degree angle. So this is it. So let us consider a complete circle which has been divided into 4 quadrants. Okay, so here E is my vector. So I am adding J to E. So what will happen when J is added to E? There will be an angular displacement of 90 degree. Okay, there will be an angular displacement of 90 degree. So when J is multiplied with E, so it will become JE. Again, if I multiply JE with J, there will be an angular displacement of 90 degree in anti-clockwise direction. And again, if I multiply J with J square E, then there will be an angular displacement of 90 degree in anti-clockwise direction. And if suppose to the J cube E, if I again multiply with J, then there will be an angular displacement of 90 degree. And at last J4E meets E. Okay, so J4E comes to the same axis where E is located. So if you observe here carefully, so the E is equal and opposite to what? E is equal and opposite to J square E. So J square E is equal and opposite to J square E. So I can say J square E is equal to minus E, or E is equal to minus J square E. Okay, so from this, whatever I have already written, okay, so whatever I have already written, based on that, J square E is equal to minus E. So E cancel. What will happen? E and E, if they cancel, J square will be equal to minus 1. J square is equal to what? Minus 1. So J square equal to minus 1 means this is it, isn't it? Now if I have J cube, I can rewrite it as J square into J If I rewrite it as j square into j, what is j square? Minus 1. So replace j square by minus 1. So minus 1 into j you will get. If I have j to the power of 4, I can rewrite it as j square into j square to the power of 2. J square is minus 1. So minus 1 square you will get 1. This is it. 1 by j is minus j. So just note it down, all these j operator terms. Note down all these j operator terms, which is important. This is important. Now let us see what is meant by resistance. Resistance is what? Resistance is the property of a conductor to oppose the flow of current. Okay, so it opposes the flow of current. So according to Ohm's law, what is resistance? Resistance is the ratio of voltage and current. We already know Ohm's law. I am not going to discuss Ohm's law. So R is equal to V by I. So R is the notation of resistance. And what are all the units? Units are ohms. Okay. So now if you represent voltage by some vector, this is voltage vector, and if you represent current by some vector, then in the circuit in which only resistors are present, in that circuit, which is if only resistors are present, then that circuit you can call it as a purely resistive circuit. Okay. So the current and voltage in a purely resistive circuit will be overlapping each other. Okay. So the voltage vector and current vector, they will be overlapping each other. So there will not be any angular displacement, phase angle we will say, phase angle displacement between voltage and current. So since they are overlapping each other, there is no angular displacement between these two vectors. So we can say that voltage and current are in phase with each other. Voltage and current, okay, voltage and current, they are in phase with each other. Okay. So this is the phasor relation between voltage and current. So draw this. Draw this. Okay. So now let us go to next term, that is known as reactance. Okay. Let us see what is meant by reactance. Resistance is what? Resistance is the property of the conductor to oppose the flow of current. Similarly, reactance also has the property of opposition. It also opposes, but it won't oppose the current directly, but it opposes any change in the current. It opposes any change in the current. Okay. So the parameters, or the circuit element which opposes any change in the current in the given circuit, okay, those circuit elements are inductor and capacitor. Okay. So alternating quantity, if there is any change in the alternating quantity, whether it is voltage or current, that opposition is exhibited by the inductive and capacitive element. Okay. So you can see here, I have written here, reactance is defined as opposition that an electric circuit component exhibits to change in the electric current due to inductance and capacitance present in the circuit. So in the circuit, if there are inductor or capacitors connected in the given circuit, then if there is any change in the current, that will be opposed by this inductive or capacitive elements. Okay, so reactance, resistance means what? Resistance is the opposition to the flow of current, whereas reactance is the opposition to change in the current. Okay, so reactance is denoted by X and it is measured in ohm. Same. Okay, unit of reactance and unit of resistance is same, and notation of resistance is R, reactance is X. Okay, so the reactance in the given circuit, the reactance in the given circuit is due to what? It is due to inductance and capacitance. Okay, due to inductive and capacitive elements, reactance comes into existence in the given circuit. So units of reactance and resistance are same, only symbol, only the symbol varies, that's it, nothing else. Okay, so if I said due to inductance and capacitance, reactance will be there in the given circuit. If there is only inductance in the given circuit, so we can call it as that reactance due to the inductive element, you can call it as inductive reactance. Okay, reactance due to inductor, if there is only inductor in the given circuit, and if there is a opposition in the in any change in the current is there due to this inductive element. Okay, that is inductive reactance. You can represent it by XL. Okay, that shows that reactance is due to inductor, so that is given by omega into L, XL equal to omega L. Omega is what? 2 pi f into L. So omega is equal to 2 pi f, so replace omega by 2 pi f into L. So what is XL now? What is XL now? XL is equal to 2 pi FL. Okay, now if there is only capacitor in the given circuit, okay, only the capacitor is there, it will also offer some reactance to any change in the current, so that change in the current is due to capacitor. So you can denote this reactive capacitive reactance by XC. You can denote it by XC. So you can denote it by XC. So XC is equal to 1 by omega C. Okay, whereas XL equal to what? Omega L. Whereas XC is 1 by omega C. Omega is what? 2 pi f. So capacitive reactance is given by XC equal to 1 by 2 pi FC. Capacitive reactance is given by XC is equal to 1 by 2 pi FC. So these two are the formulas for inductive reactance and capacitive reactance. Just note it down. Note it down. This XL equal to and XC equal to. Okay, now let us see the vector relation. We have seen the vector relation for resistor of voltage and current for the resistive circuit. Now let us consider an inductive circuit. Inductive circuit, if it is purely inductive circuit, then the relation between voltage and current vectors of inductive circuits will lie in such a way that the voltage, inductive voltage, okay, will always lead current vector, current flowing in the circuit, by an angle of 90 degree. How can I say voltage is leading? We should always move in anti-clockwise direction, okay, from x-axis, to know which parameter is leading and which parameter is lagging. So when we are moving in anti-clockwise direction, what we can see is VL is ahead of I by an angle of 90 degree. By an angle of 90 degrees. So if it is a purely inductive circuit, then the voltage of the inductive element, okay, or of the voltage across the inductor will always lead the current in the circuit by an angle of 90 degrees. Similarly, if it is a purely capacitive circuit, then the voltage Vc, if it is a capacitive circuit, the voltage Vc will lag current I by an angle of 90 degree. For capacitor, voltage will lag, okay, you should always move in anti-clockwise direction. Voltage will lag. For inductor, voltage will lead. So in other words, I can say, for capacitive circuit, current will lead voltage by an angle of 90 degree, whereas for an inductive circuit, voltage will lead current by an angle of 90 degree. Or I can say that for an inductive circuit, current lags voltage by an angle of 90 degree. Okay. So for capacitor, voltage lags current by an angle of 90 degree. So this is the phasor relation between the current and voltage. This is for inductive circuit. This is for capacitive circuit. Okay. So draw these two. Okay, now let us see the next one, that is impedance. So impedance, it is the measure of opposition to the current flow when supply voltage is given to the circuit. So impedance is what? It also opposes the flow of current whenever current flows in the circuit because of the applied supply voltage. Okay, so its properties are almost similar to resistance. Okay, resistance property. Okay, but if I want to measure impedance, the impedance is the cumulative effect of both reactance and resistance. Okay, it is the cumulative effect of both reactance and resistance. Impedance is denoted by Z. Okay, and it is given by Z is equal to R plus JX. So where R is what? R is the resistance and X is the reactance. So it can be, X can be inductive reactance or capacitive reactance, or it can be both inductive and capacitive. So Z is equal to R plus, so reactance value, it is, you can it is usually what to say, there will be phase angle displacement. So there will be angular displacement between the R and X. Therefore the X is X is multiplied with the J operator. Okay, X is always multiplied with the J operator. Why? Because there will be an angular displacement between R and X. You can see here, this is R. If this is R, then X will, if R is lying on X axis, then X will lie on the imaginary axis, that is on Y axis. So there is an angular displacement of what? 90 degree. So we already know that J operator will be multiplied with any term when it is, when there is an angular displacement of 90 degree here. So in anti-clockwise direction. So here it is R plus Jx. So if Z is equal to R plus Jx, impedance, Z is impedance, then Z square will be equal to R square plus X square. Z is equal to root of R square plus X square. So this is the impedance formulae. Z is equal to root of R square plus X square, where R is what? It is the resistance and X is the reactance of the given circuit. Okay. Now You can represent this r and x in terms of vectors. This is my r vector, this is my x vector. So r plus jx, vector sum of r and x is nothing but impedance. So you just draw a diagonal here, put a dotted line from x and put a dotted line from r, and wherever at whichever point they intersect, that is our impedance. So the diagonal of this r and x is the impedance value. So the length of this diagonal will give us the impedance. Let us assume z is making an angle of theta with respect to r here. Okay, z is making an angle of theta with respect to r. What is this dotted line length? It is nothing but x value. So what is this length? This length is nothing but, what is this? This length is x. So this is x, this length is x. What is this length? R. Okay. So you can consider this right angle triangle. You can consider this right angle triangle. What is tan theta? What is tan theta here? Tan theta is equal to opposite x, opposite by base, x by r. So what is theta here? Tan inverse of x by r. That's what I have written here. So the angle between applied voltage and current will be what? Theta equal to tan inverse of, what is it? What did I write? Tan inverse. Something is wrong. One second. Yeah, it is x by r. Yeah, here it is reverse. I'm sorry. Here it is x by r. Okay, theta equal to tan inverse of x by r. Here I have written the numerator, I have written the denominator, I have written. So what is theta now? Theta is equal to tan inverse of x by r. Okay. So what is z? Z is the vector sum of r and x. What is x? X is the reactance. Okay. Now let us see in this table. If it is a purely resistive circuit, symbol of resistor is r. What about the purely resistive means? What is the reactance in the circuit? 0. So the impedance will be what? Equal to r. Impedance in the circuit will be equal to r, because x value is, what is z? Z is equal to r plus j x. X is 0. So what will happen to z? Z will be equal to r. Now if it is purely inductive circuit, r will be 0. Reactance is omega L. Reactance is omega L. So if reactance is omega L, then z will be equal to jx. What is x? Omega L. So zl is equal to j omega L. And here r is on the x axis, the angle is 0. Okay, so it is a phase angle between voltage and current. Angle between voltage and current is 0. Similarly, angle between voltage and current is how much? 90 degree. Okay, it is plus 90. Why? Because here voltage is leading current, therefore plus 90. So if it is a capacitive circuit, what about resistance in a capacitive circuit? 0. And what about reactance? Reactance in a capacitive circuit is how much? 1 by omega c. So reactance is 1 by omega c. So what about Zc? Zc is equal to j into 1 by omega c. So if you represent in terms of angle, so 1 by j omega c at an angle of minus 90. Why minus 90? Because current is leading voltage by an angle of 90 degree. So just note down this table. Let us see what is meant by admittance. So admittance is reciprocal of impedance. Impedance is what? Z. Okay, impedance is Z. So reciprocal of impedance is admittance. Admittance is denoted by Y. You can see here Y. Admittance is denoted by Y. So Y will be equal to 1 by Z. So unit of impedance is what? Ohm. Similar to resistor. Resistor, reactance and impedance. These three terms will have same units, ohm. So what is the unit of admittance? It is mho, MHO, mho. So it is reciprocal to the impedance. Okay. So what is the property of impedance? It opposes the flow of current. Okay. So admittance is reciprocal to impedance. So that means impedance will allow the flow. Admittance will allow the flow of current. Okay. So admittance will allow the flow of current in the circuit. Impedance will oppose the flow of current in the given circuit. So its symbol is this. This is the symbol of admittance. Okay. So what is Z? Z is equal to R plus JX. So Y is G plus JB. Okay. Where G is the conductance and its units is in Siemens, and B is the susceptance. B is known as susceptance and its units is also Siemens. Okay. So this is it. Admittance is measured in terms of conductance and susceptance. Impedance is measured in terms of resistance and reactance. Now let us see what is meant by rectangular form. Okay, so rectangular form means if you represent any equation in terms of a real value and imaginary value. Imaginary value means if any term is multiplied with j operator j, then it becomes an imaginary value. So you can see here r is not multiplied with anything. R is not multiplied with anything. Okay. So r plus or minus j x. X is multiplied with j. So this has this z is equal to what? R plus z is equal to r plus, I'm sorry. So z is equal to what? R plus jx. So jx is the imaginary part, r is the real part. So if any term has a real part and an imaginary part, if both parts are there in that term, that is known as rectangular form. Real part plus imaginary part, plus or minus. It need not be always plus, it can be plus or minus. So this is my rectangular form. If I want to determine the magnitude, okay, if I want to determine the magnitude of this rectangular form, simply take the square root and square those terms. Okay, forget about j. Okay, so root of r square plus x square will give me the magnitude. If I want to determine the angle, it is given by tan inverse of imaginary term by real value, imaginary value by real value, j operator coefficient by real value. So theta equal to tan inverse of x by r. So if this is in rectangular form, so if you convert that into polar form, polar means it will have a magnitude and angle. So just now we have calculated magnitude. How to calculate magnitude for this rectangular form? Simply take the root of r square plus x square, you will get the magnitude. If you want the angle, theta equal to tan inverse of imaginary term coefficient by j operator coefficient by real value. So these two terms together, they form a polar form. So what is it? Magnitude z at an angle of what? Plus or minus theta. So I have converted, what did I do? I have converted rectangular to polar. Rectangular to polar form. If I want to convert rectangular values to polar, I can use this method. So if I have polar form, that is magnitude, z magnitude and angle theta. If I have polar form, then if I want to convert that into rectangular, what I have to do is, for in rectangular there will be two parts, real part and imaginary part. Real part r is equal to magnitude into cos theta. Yeah, I will get the real value. imaginary part if I want, then take imaginary x is equal to magnitude z, multiply it with sin theta. Okay, you will get the r value and x value. In rectangular form, just write it down. Z is equal to r plus or minus jx is the rectangular form. So, if you have polar, by using these formulas, you can determine the rectangular. If you have rectangular term, okay, if you have rectangular terms, you can, by using these formulas, you can determine the polar form. Okay, so let us solve some numerical problems, and I will conclude this class after solving the numerical problems. So, an non-inductive resistor of 10 ohms, a capacitor of 100 microfarad and an inductor of 0.15 Henry are connected in series to 240 volts 50 Hz supply. So, a resistor of 10 ohms, capacitor of 100 microfarad and the inductor of 0.15 Henry are connected in series. These three elements R, L, C are connected in series across what? Across 240 volts 50 Hz supply. Calculate what? Inductive reactance, capacitive reactance and circuit complex impedance. We have to calculate reactance, inductive reactance, capacitive reactance and impedance. Just write down this question and draw this circuit. I will conclude within 5 minutes. Okay, then we have to calculate what? Inductive reactance and capacitive. I will just copy this. So, our circuit is this. This is our circuit. Now, what is the formula to determine inductive reactance? 2 pi FL. XL equal to 2 pi FL. F is given 50. L value is what? 0.15. You know 2 and pi are constant. Just substitute it. 2 pi into F value 50 into L value 0.15. Just solve it. You will get 47.13 ohms. Okay. So, next if I want to determine capacitive reactance, formula is what? 1 by 2 pi FC. 2 pi is constant, F is 50, C value is what? 100 microfarad. Micro means 10 power minus 6. Micro means 10 power minus 6. 100 into 10 power minus 6. Okay. So, you just substitute all the values in this. You just substitute all the values in this and you will get XC is equal to 31.83 ohms. Now, impedance Z formula is what? I'll just expand it. Okay, so z is equal to what we have already learned is that z is equal to root of r square minus x, sorry, not minus, root of r square plus x square. So what is this x? X is equal to xl minus xc. You can write xc minus xl. You can write xc minus xl if xc is greater than xl. So here I have written xl minus xc. Why? Because xl is greater than xc. You just see here, xl is 47 ohms, xc is 31 ohms. Since xl is greater than xc, I have written xl minus xc. So what is z now? Z is equal to root of r square plus xl minus xc whole square. Okay, so this is it. So you know r value, you know xl value, you know xc value. Just now we have calculated xl and xc. Substitute in this and simplify, you will get 18.3 ohms. Okay, so r value is 10 ohms. It is given in this circuit, and we have just now we have calculated x l and x c. Okay, so we have calculated xl and xc. So substitute xl and xc here in this impedance formula. So this is the impedance given in the asked in the circuit. This is the capacitive reactance. This is the inductive reactance. Okay. So let us go to the next numerical problem. A circuit has a resistance of 5 ohms, okay, in series with a reactance across an inductor of 3 ohms. Represent the impedance by complex number in polar form. Okay. Okay, so here there is a resistor and an inductor. There is a resistor and an inductor. Both are connected in series. Both are connected in series. I am going to draw this circuit. There is a resistor and an inductor. Okay, so both are connected in series R and XL. Okay, and XL value, did they give XL value? They have given inductive reactance, inductor reactant. Ohms means reactance. So R value is 5 ohms. So here I have written R value is 5 ohms, XL value is 3 ohms. What is Z? Z is equal to R plus Jx. Okay, Z is equal to what? R plus Jx. Okay, so what is R? 5, X is 3. So Z is equal to 5 plus J3. So I want to determine the impedance in polar form. So what is the formula in polar form? I need a magnitude of Z. So I will write Z here and I will put like this. So this is my z. So magnitude is root of r square plus x square. So what is r square value? R value is 5. So 5 square magnitude of z. I am determining the magnitude of z. Magnitude of z is equal to 5 square plus, what is this? 3 square, x value is 3 square, under root. So 5 square means what? 25 plus 9. Okay. So root of 25 plus 9. So it is approximately root of 34. Root of 34, if you simplify, you will get 5.83. 5.83. Okay, this is the magnitude. Now angle theta equal to tan inverse of x by r. So tan inverse of x is what? 3, r is 5. So substitute determine tan inverse of 3 by 5, you will get angle as 30.96. So they have asked us to determine the impedance. They have asked us to determine the impedance in polar form. They have given us resistance value, they have given us inductance value. That too they have mentioned that it is the reactance of the inductor. So both are in ohms. R value, XL value is given. So you can determine impedance R plus JX. Okay, and convert that into polar forms. Here small r means magnitude of impedance. So instead of that you can write Z. Okay, magnitude, and this is the angle of the impedance formula. So substitute all the values which are already given in the problem, and you can determine the unknown terms. Note it down in your notes.